Okay, continuing with MAC1105 lecture video, section 4.1. We had done examples 1 through 5. We are now on example 6, which says write the equation in standard form of a parabola that has the shape 6x squared. This 6 determines the width as well as the direction that the parabola opens in. So we're going to use the fact that the equation can be written from this formula. A is the coefficient of the squared term, and then it goes x minus the h coordinate at the vertex plus k. So this is the standard formula for a parabola, and basically we have everything we need, so there's really hardly any work at all for this problem. We have the a value, which is this 6 right here. And we also have the vertex. The coordinates are 4, so this would represent the h value. This would represent the k value. So it's x minus h. Remember, what the sign that the number appears as in the equation is the opposite of what it appears as when the h and k are listed as a point. That h value always has the opposite sign because the formula has a minus in front of the h. The k, however, will appear just as you see it here. And that is the function. That's all you have to do for example 6. When we get to example 7 and 8, then we get much more involved because these are application problems. So in these two problems, what you see is someone releasing a shot. They're throwing a shot put, and it's releasing, it's going up and then falling down, and therefore follows a parabolic curve. So it's described here in this paragraph. It says that an athlete whose event is the shot put releases a shot. When the shot whose path is shown by the graph is released at an angle of 30 degrees, its height, f of x, in feet, can be described or modeled by the following function. F of x is equal to negative 0.01, negative a coefficient, explains why it's opening downward, as all things do, as the parabolic curve always is. Whenever you throw something in the air, it's going to fall down, forming a downward parabola, plus 0.6 times x plus 6.2. So that is the function that models this curve, where x is the shot's horizontal distance in feet from its point of release. Use this model to solve parts A through C and verify your answers using the graph. Okay, so in part A it says, what is the maximum height of the shot and how far from its point of release does it occur? So really they're just asking the same question here in example 7 as they've asked in previous problems. Basically, what's the vertex? Because when you're asked about the maximum or the min, they are referring to the vertex. So remember that when you are finding that maximum y value, which they're referring to as height, maximum height, you need to find the x value first. So find the x value first. And at the vertex, don't forget, that is found by this formula, negative b divided by 2a. Once you find this value, then you are going to find this y, this maximum y value, or in other words, the height, by substitution. Okay, so we'll find that maximum y by substitution, just as we have in the previous problems. So in part A, let's find x first at the vertex, which appears to be right here. We're going to find those exact values. Don't try to eyeball the values in the graph because sometimes they look like they're at a certain value and they're just a decimal or a hair away, and you have to give exact values when you're in the software doing your homework. So do them using the formulas that we've been practicing throughout this section. Okay, so x is opposite of b over 2a. And those values would be This is A, and this is B. So you're going to go opposite of 0.6. You can write the 0 if you want, but you don't need zeros that are in front of the decimal. You can do the calculations without. And then we're going to go 2 times the A value at the bottom. Let me just move this over. And that would be negative 0.01. Okay, you can go ahead and put that in your calculator. I can just find mine. Okay, so it's negative 0.6 divided by 2 times negative 0.01, and that is 30. And I believe this is in feet. Occurs at 30 feet. The maximum height associated with this would just be the y partner. So now we want to know, what is the y value associated with this particular x? And every time we were finding the maximum value, we always had to find the x first, then plug in that x into the function in order to find the y value associated with it. So now it's the function with 30 plugged in for x. This is just an announcement about what I'm about to plug in. And then using this function rule right here, I'm not going to put that 0. I'll put in the 30 wherever there's an x. And then I'm going to go to my calculator and find that y value. F of anything can be renamed y, or you can leave it as is. Okay, so it's negative 0.01 times, and then we're going to do 30 squared plus 0.6 times 30 plus 6.2. And you get 15.2. And again, this is in feet. So the maximum height is 15.2. That's what that value is. See, it looks like it's 15, but it's really just a hair off of that. So maximum height that it reaches is 15.2 feet, and then it starts falling. And then that occurs at an x value of 30. So basically we just found the vertex. 30 was the x coordinate, or what we call the h value, and 15.2 was that maximum y value. Okay, part B. What is the shot's maximum horizontal distance? Well, when you're finding the maximum horizontal distance, you're looking at this picture. Notice that it reaches a height, it starts falling, and then this would be the maximum horizontal distance. Notice that when it goes as far as it can go horizontally and hits that x-axis, that is also known as an X-intercept. And we've also been practicing throughout this section over and over again in all the problems how to find X-intercepts. So remember, when finding an X-intercept, you just let y be equal to 0. And you solve the equation that results. Okay, so let's take this function. We'll look at it up here. This represents y, this entire name right here. And so we are letting that entire name, f of x, be equal to 0, as stated here. And then we're copying the other side, negative 0.01 x squared plus 0.6x plus 6.2. We're going to solve this by quadratic formula. Okay, we want to know what that x value is, where it hits this positive x value, where it finally reaches its maximum horizontal height, horizontal distance. Okay, remember this is the a value, this is the b value, This is the C value, and you will need all three of those as you do the quadratic formula. So let's recall that formula. X is equal to opposite of B plus or minus B squared minus 4 times A times C all over 2A. Okay, let's plug in those numbers. We're going to really need our calculator here. So it's opposite of the B value, 0.6, plus or minus the B value squared plus 6.2 divided by 2 times the A value. We're going to plug all of this into the calculator. Okay, so here we go. I'm going to do this in pieces so I can be as accurate as possible. So we have just negative 0.6, nothing to do there. But I do want to find out what's underneath. What is the square root of what's underneath here? So first I'm going to do what's underneath it, 0.6 squared plus 6.2. Okay, so 0.6, square that, you get 0.36, that's that, plus 6.2, you get that. So that is the number that's underneath here, 6.56, and I want to take the square root of that. So second square root, dump that answer right under here by pressing second answer, close it up, and you have, I'm going to carry this out to 2.5612. You really shouldn't round so severely until you get to the final answer. Divided by negative, and you can put this in if you want to, 2 times negative 0.01. That's really negative 0.02. Okay, so let's get the two values here and see which one doesn't make sense to keep as an answer with respect to x. Remember, you want a positive x value. You can see that when it goes as far as it can go horizontally, that it hits as a positive x value. In fact, there are no x values. So therefore, anything that's negative is not going to make sense. Now you can possibly tell, if you're looking at this, what the negative x value is going to be. If you went negative 0.6 and then you subtracted an even more of a number, this is going to be negative. When you go negative 0.6 minus 2.5, so let's not even bother doing that answer. Instead, we'll only keep the answer that goes, let's see. Actually, we're going to be dividing by a negative, so that one is going to, that's actually going to be the one we're going to keep. So I'll show you both of them, and just so you can see what they look like at the end. Okay, so it's negative. Let's go ahead and do this answer. Negative 0.6 plus 2.5 plus 2.5612 divided by negative 0.02. We can pop that in our calculator. So negative 0.6 plus 2.5612, that's the top, divided by negative 0.02, and that comes out, see how that comes out to be negative 98.06? Okay, so right here that this is impossible because you see that it's landing at a positive x value. So this is impossible with respect to the problem, so we're not going to keep this answer. It's probably good to put it in your notes. The other answer that this gives from the quadratic formula is x equal to negative 0.6 minus 2.5612, then finally divided by that negative 0.02 that's at the bottom. Now that one comes out positive, so it's the only one that makes sense with respect to this particular application problem. So negative 0.6, that's that, minus 2.5612. There's your top, your numerator, divided by negative 0.02. and that's 158.06. And we just make sure all the calculations are right here. So I copied this problem from up here. Let me check everything. It's 0.01 x squared plus 0.6. That is the second term, and then plus 6.2. Okay, just making sure I copied all of that. And so when you wanted to know this x-intercept, that is a point when y is equal to 0. So this being where f of x usually is, f of x is equal to all of this. I put a 0 in place of that y value. You then end up with this quadratic equation, second degree, first degree, 0 degree. And whenever you have an equation like this and you're wanting to find the solutions, you can either factor or use the quadratic formula. I used the quadratic formula. So I went opposite of the b value, which was opposite of 0.6, plus or minus that b value squared again, plus 6.2. Then down at the bottom, it was 2 times negative 0.01. Okay, I want to make sure that those calculations are right. So negative 0.6. I'll make sure this is right. So 0.6 squared. Oh, there's the mistake right there. Let me fix this. Felt like there was something wrong there. Okay, so this was 0.6 minus 4 times a, and that a value was okay. So this was minus 4. I just put a 6.2 there. So minus 4 times a would be negative 0.01 times the c value, which was 6.2. I did not put everything I needed there. So sorry about that. Okay, let's calculate this again. Okay, so now I have opposite of b, b squared minus 4 times a times c. Okay, so what's really underneath here is 0.6 squared, which is 0.36. And then I'm going to go negative times negative, which will be positive. So if you just want to go 4 times 0.01, so this is going to be plus 4 times 0.01 times 6.2. And that would be 0.608. Okay, so square root of 0.608 is second. Square root 0.608, close that, and you get 0.77. So this is negative 0.6 plus or minus 0.7797. And then we're going to be dividing by negative 0.02. Okay, so let me fix this. Feeling something was going wrong with this answer, and good thing I caught it. Okay. All right. Squared plus 4 times 6.2 second square root 0.608. Okay, so now putting this in the calculator, here are my two answers for x. One more time. So we can do negative 0.6 plus 0.7797 divided by negative 0.02. That would be one answer. Let's see if this answer makes sense. So it would be negative 0.6 plus the answer that's still in the calculator window. And that would be my top, divided by negative 0.02. And see, that would be negative. It would be negative 8.99. Okay, so this answer is not possible, or you can write it does not make sense with respect to this problem. And then you can find the other answer. So the other answer would be negative 0.6 minus 0.7797 divided by negative 0.02. And that answer would be negative 0.6 minus 0.7797. That would be my numerator, divided by negative 0.02. And then the answer would be approximately, if I round off to the nearest whole number, that would be approximately 69. Let's see if they want you to round off to a bit. Yeah, let's see. Round to this nearest tenth of a foot. Okay, so this rounded to the nearest tenths. This is the tenths place. This is going to round up to a 10 because of the number next to it. And the 1 from this 10 that this is rounding up to carries over to here. So this would be 69.0 rounded to the tenths place. Okay, and we are in feet. So this is the maximum horizontal distance. And you know, they're telling you to verify this by using the graph. Well, you can see that on the graph it looks like it hits right on 70, but again, what the graph looks like and what the exact answers are can be slightly off in most of the cases. So make sure that you are using the procedures that were taught in this section for finding maximum points, maximum values, for finding X-intercepts, because that's really what this problem is about. It just happens to be in the form of a word problem, an application problem. Okay, part C. From what height was the shot released? Well, when it's released, right at the moment when it's about to be released from the person's hand, the horizontal distance that it has traveled is 0 feet. So this is at the point of release. The object, or the shot in this case, has traveled horizontally 0 feet. Okay, that's the same thing as saying you're going to let x be equal to 0, and you want to know what is the y partner at that point. So, from what height? That's how I know I'm looking for the y value, because height refers to your y value. Was the shot released? They're talking about at the point where x is equal to 0. What is y? Point of release is always at x equal to 0. Okay, so using the function above, I'm evaluating at x equal to 0. So here's f of x is equal to negative 0.01. I'm just copying that function above, again, allowing x to be 0 each time I see x. Okay, that would give me that. This times this is just 0, so that whole term is gone. This times this is 0, so that whole term is just gone, and you end up with just 6.2. So the y value when x is equal to 0 is 6.2, and this would be the height at the point of release, when the shot is released. Okay, so answer that was this. This was 69.0 feet for part B, and for part C, it was 6.2 feet. Okay, so that gives us everything. 2 answers for part A. This was the answer for part B. And finally, this was the answer for part C. So, pretty involved problem. Okay, last little application problem in this section is example 8. And in example 8, they give you a diagram, and they are asking questions concerning area. They tell you that the length is represented for this rectangular fenced-in yard. It says the farmer has 450 meters of fencing and wants to enclose a rectangular plot that borders on a river. So that's the river, and that's not going to, there's no fence along there, but there is fencing along these 3 sides. So he's got 450 meters to work with. We don't know how much he's going to lay across each of these widths. And the length, this is just what's left over after he uses X meters here and X meters here. Then what would be left over is the 450 that he started with minus 2x. So this represents your length. These x's represent the width. And each of these questions has something else that they are concerned with. So in part A, it says the width, labeled x, in the figure is how many meters? And the question that they're getting at here is, if he doesn't fence the side along the river, so that's not fenced in, find the length and the width of the plot that will maximize the area. And if they're asking you to maximize the area, then they're really asking you to find the vertex. And that's been one of the main things that was emphasized in this section. Okay, when you find the vertex, you're finding H and K. You could also call it X and Y. And you know that you can't get to the Y value before finding the X value. So in this particular problem, if we want to find this X right here, we're going to start off with the formula for finding always this H coordinate, or what we call the X value, which is negative B over 2A. Okay, so now if we're going to be able to tell what the B and the A value is, we need an equation. So since they're asking you to maximize area, there is an equation that you can come up with. Area is equal to length times width. Well, the length here is 450 minus 2x. And the width that we're multiplying it by is just x. And if you multiply or distribute this x into the terms that are inside the parenthesis, you get as your squared term negative 2x squared. That's one of the terms that you get. And when you multiply it by this front term, you get positive 450x. So the reason that this is in the section concerning parabolas is because it's a quadratic equation. So the area in terms of x, just writing it in function notation, would be negative 2x squared plus 450x. So with respect to what we were trying to find, the maximum width This equation will help us find this because that makes this the A value and it makes this the B value. The coefficient of the square term is always A, coefficient of the linear term is always B. So now we can do this. Okay, opposite of the B value, this would be 450. Opposite, and then it's 2 times A on the bottom. So 2 times negative 2. Okay, so this would be negative divided by negative. If you don't want to put the negatives in, they do cancel. That cancels with that. So we're just looking at 450 divided by 4. And that turns out to be 112.5, and I believe we are working in meters in this problem. Okay, so this would be 112.5 meters. Okay, then going on to part B. The length labeled 450 and then 450 minus 2x in the figure is how many meters? Again, with respect to maximizing the area. So if you want to find the maximum y value associated with the x at the vertex, then all you have to do is plug this value in to the function. So you're going to find the maximum y value, as we always have, by knowing what the x value is at the maximum point. And that x value was 112.5. So let's get here into our function. Right here. And we're going to take it and evaluate it at 112.5. Okay, so we're going to go -2. And actually, let's see, what do they want? They want the maximum length here. So let's use this. They want the maximum length in this particular problem. And the figure is how many meters. So yeah, that's what we're going to use here. Maximize the length. So that would be 450 minus 2 times whatever the x value was, and that maximum x value turned out to be 112.5. So they didn't ask us to maximize the area yet. They wanted just the maximum length in this particular problem. And then in part C, they're asking us for the maximum area. So we'll wait on using this area formula until part C. So this would be 450 minus 2 times 112.5, which is the same thing as 450 minus this times this is 225. So 450 minus 225, and that's 225. $325 meters. Okay, so that's the answer there. 225 meters. Okay, so we substituted our x value in for length, and we got the maximum length. Then this next question says, what is the maximum area that can be enclosed? So when they ask for the maximum area, that's when we're going to use this formula here. Which is just the maximum length times the maximum width. That maximum length that we ended up getting was 225. And the maximum width was 112.5. So we're working with area now, and we found out what the maximum dimensions were for length and width, and therefore the maximum area would be 225 times this. 225 times 112.5, close that up, whoops, 225 times 112.5, and that is 253,25312.5, 225,312.5. And since we're doing area, it's meters times meters. This would be meters squared. Okay, and that completes section 4.1.